So what Descartes' rule is allows us to do is to be able to find out how many positive real zeros there are a polynomial has and how many negative real zeros a polynomial has. So you have to look at two things. So we want to look at the positive real zeros, and to look at the positive real zeros, you always look at the original function, the original polynomial. So in this case, it's negative 2x cubed plus 6x squared minus x minus 4. And then we want to look at the signs. So to look at the signs, you look at each term in the polynomial. So for the first term, negative 2x cubed, it's negative. Then the next term is positive. The next term is negative. And the next term is negative. Then you want to look at the sign changes. So I'm going to say, okay, here it goes from negative to positive. So yes, there's a sign change. Next, we have from positive to negative. That's another sign change. We go from negative to negative, and that is not a sign change, stays negative, so we don't count that one. So what Descartes is telling us that this polynomial could have two real zeros, so two positive real zeros, two positive real zeros. Or another option is you always want to say 2 minus 2. You always want to subtract 2. So 2 minus 2 is 0. So this polynomial could have either 2 or 0 positive zeros. Okay? So that would be your answer for the first part. For the negative real zeros, you have to look at q of negative x. When you look at q of negative x, you have to plug in negative x for whenever you see x. So you have negative 2 times negative x cubed plus 6 times negative x squared minus negative x minus 4. So when we look at this right here, right, this is going to become a negative. So the negative times negative 2, so you're going to have 2x cubed plus 6x squared when you simplify, and then you have plus x minus 4. So then I'm going to look, remember I have to look at the sign. So the first term is positive, second term is positive, third term is positive, last term is negative. So when I look at how many times it changes sign, so it goes from positive to positive, so that's not a sign change. It goes from positive to positive, that's not a sign change, and then it goes from positive to negative, that's a sign change. That's what we want. So here what this is saying is, since you only have one number, you cannot subtract. If you subtracted 2 from 1, you would have a negative number, so you cannot have negative 1 real zeros. So here what it's telling us is since there's only one possible change, we'll say that this polynomial has exactly one negative real zero. So if you actually were to graph this function, you will notice that the function is going to look a little bit like that. Oh, sorry, where this is the x-axis, and you have the graph intersects here. So this right here is your negative real zero, and then right here are your two positive real zeros. So just by looking at Descartes, you couldn't have known that there were two, but you have either 2 or 0 positive zeros. You would have to know a little more information to actually do this graph, but it gives you a good start to know a little bit about the behavior of the polynomial and how many zeros it has.